Imagine you are floating in orbit, right next to a dying supermassive star. You are about to witness the brightest explosion in the known universe. The sheer volume of energy tearing outward is almost impossible to comprehend. But as the blinding light washes over you, your ears register nothing. Absolute, complete silence. It isn't because you are too far away, and it certainly isn't because the explosion lacks physical force. The reality is that the conditions out here make it physically impossible for sound to exist. The environment itself actively prevents acoustic noise, forcing us to separate the idea of extreme destruction from the expectation of a loud crash. To understand why, we have to look at how we experience noise here on Earth. Down here, an acoustic wave cannot travel on its own. It requires a physical material to ride through. When you speak, the atmosphere provides that material, carrying your voice's vibration across a room. Deep in the ocean, dense liquid water does the same job, allowing whales to communicate across miles of sea. Even solids work, like the way a metal rail carries the rumble of a distant train. These materials are densely packed with particles. When a vibration starts, it knocks into an atom, then its neighbor, creating a continuous domino effect. But when that chain reaction hits an empty void, the wave instantly dies. There is nothing to push against. Noise is a mechanical chain reaction that relies entirely on the structural density of its environment to survive. Now, take that mechanical requirement back out into the vastness of the cosmos. Away from planetary atmospheres, space operates almost entirely as a perfect vacuum. There are a few stray atoms drifting out there in the dark. On the left are tightly packed Earth atoms. On the right, the massive gaps between isolated atoms in space. If a wave initiates here, it might bump a single isolated atom, but the kinetic energy dissipates immediately. It can't reach the next atom. The immense physical separation between matter prevents any continuous wave from crossing the gap. That vacuum acts as the ultimate acoustic insulator. No matter how violently matter collides out there, the kinetic chain reaction is trapped entirely at the source. Which brings us back to our position beside that detonating star. This chart compares the energy output of a supernova to a standard star. In a matter of seconds, this single blast dwarfs the total energy our sun will produce over its entire multi-billion-year lifespan. Floating nearby, your brain expects an explosion of this magnitude to shatter your eardrums. You receive all of the visual evidence. Photons don't need a physical medium to travel, so the blinding light cuts effortlessly across the vacuum and reaches your eyes. But because there are no particles to carry the physical shockwave, the acoustic energy never crosses the gap. Across the universe, massive galaxies are colliding, black holes are tearing stars apart, and supernovas are erupting in the dark. The deep mystery of the cosmos doesn't stem from a lack of dynamic or destructive action. It stems from the fact that the most powerful events in nature occur in total, unyielding silence.